Hey everyone, so today what we will be doing is we will be solving this problem right here. So it says that there are 6 points different from each other on the two straight lines, which means there are 12 points in total. And they're asking us how many triangles which are different from each other can be drawn by using any three of those points. Okay, so here are some formulas that will help you in this problem as well. So before we move on to the problem, let me explain this part to you. So let's go to the first theory. So this theory is related to binary coefficient, which is a stream in combinatorics. So let me explain you what is this mean. So this problem is read as n choose k if you talk about left side. So if I explain what is n choose k, it'll be something related to sets. If we say that there is a set with n number of elements, and then we have to choose k number of elements from it. How many possible ways are there that we can do that? So this is the formula that we can use to find that. So here you have this exclamation mark for each of these, right? So this exclamation mark is called the factorial. So which means n choose k is n factorial divided by k factorial times factorial of n minus k. So now let's talk about what is factorial. So if we take n factorial, it would be n and then a value less than 1 and then a value less than 2. And just like that, we're going so on as a countdown starting from n, and we have all of those values, right? We're going to multiply all of them. Now, if we take 5 factorial, it'll be 5 times 4 times 3 times 2 times 1. And that's over. We're not going to do 0. So that's the value of 5 factorial, and if you simplify it, what you will get is 120. So now let's move on to the problem because now we studied both of the formulas. So let's try to understand what is the way that we can draw at least one triangle. So here if we take two lines like this, and let's assume that there are 3 points in each. So we have 3 points on this line, which means we can match them to create a triangle, alright? But you can't because the 3 points are collinear. So if we study the composition of a triangle, there are 2 points in the base, and then there's another point remaining. If we take any side as the base, the same thing will happen. So which means we have to we have to select 2 points from here, and then we have to match it with a 1 point in the other line. And we can do the same thing by selecting 2 points from here and matching it from here. And now you have a triangle right here as well with these 2 points joining this one. So there are numerous ways that we can do this selection, and we can just calculate it by drawing all of them. It'll be messy and difficult to do, and it'll waste your time. Because, for an example, for this test that I took this question, they only gave an hour to do the total test, and it had 20 questions. So, which means, in average, you have less than a minute. I think, yeah, you have 60 minutes, and Oh wait, you have 3 minutes to do one problem. Sorry about that. So you have 3 minutes to do one problem, and you can't draw them and count them in a duration of 3 minutes. That's impossible. The answer for this is really big, based on what it seems. So now let's go to the solving part, because now we just explained how the composition works. So which means we'll have to select any 2 points from one line, and then we'll have to take 1 point from the other line, and then we'll have to take a two selection and one selection, and then we'll have to match them. So first thing that we have to do is we have to select 2 from 6, which means we have to choose 2 from 6. Which means this basically means the binary coefficient 6 choose 2. So we have to solve this. So let's attempt to solve this. So then if I substitute the values of the formula and write the whole expression again, it will be looking like this. Okay, so 6 choose 2 is 6 factorial divided by 2 factorial times factorial of 6 minus 2. So let's calculate each of these factorials one by one. So if we can remember some of the general factorial values, you should remember that 5 factorial is 120. So we can just multiply by 6 and we'll get 6 factorial as 720. Or you can multiply 6 times 5 is 30, 30 times 4 is 120, 120 times 3 is 360, 360 times 2 is 720, 720 times 1 is 720. Now we're moving on to 2 factorial. 2 factorial is obvious, it's 2, because 2 times 1 is 2. And now we can't simplify this factorial right now. We'll have to simplify this parenthesis first. So that parenthesis right here will be 4. So now we'll have to count for factorial. So it'll be 4 times 3, 12, 12 times 2, 24, 24 times 1, 24. So now we have this as 6 choose 2, but still we can simplify this, right? We can multiply this by 48, but I think it will be easy for us if we cancel out values. So we can take this 2 right here, and then we can cancel out a divided by 2 here as well, so it'll be 180 divided by 24. Now you can divide both sides by 6, so you'll have 4 divided by 30. Wait, I think we got the calculation wrong at a point. Let's just review the part very carefully. So first we can cancel out a 2 right here. And here what we will have is 360. That's the point I did wrong. So here, if we take the 24, we can divide this first by 12, so we'll have 2. Then we can divide this by 12, so then we will have 30 as the remaining. And then we can divide this whole fraction, and then we have 15. So 6 choose 2 is 15, which means there are 15 ways that we can choose 2 elements from 6. So if we draw all of the 15 possibilities where we can choose 2 points, where we highlighted 2 points, there are 15 possibilities for now. And from each of those 2 points, we can combine them at any of the other points on the other line. So there will be 6 triangles on each set. Let me explain it to you. So let's assume that we choose the first 2 points of the top line. And then we combine them right here. We have a first triangle. And then the same thing happens here. And here. And here. And here. And here. And here. Like this. It might not be the best triangle, but still I hope you understood it. So apparently there are 6 ways in each of the parts. So which means in there we have 15 times 6, which is 90. But that's from the top line perspective. But we can choose 2 points from the bottom line as well, and then we can combine them at 1 point in the top line. So here also the same amount will be there, 90. So we can just easily add 90 plus 90, which will be 180. So which means this is the final answer for our problem. 180 is the number of triangles that we can draw. So I hope you enjoyed solving this video. Make sure to subscribe to my channel and share it with your friends. And I hope to see you in another video. Take care.